Hello grade 12s, welcome to the other lesson on organic chemistry. We're going to do the June 2016 past paper National Senior Certificate. Alright, so now let's get to it. We are of course going to be using our summary. I'll keep on emphasizing the summary, okay, because it's very important guys. This is the summary that we have here, and we're going to use it to answer the questions. All right, now let's get to it. Question 6 here. The flow diagram. We're given the flow diagram below, and it shows prop 1 in. It can be used to prepare other organic compounds. All right, we can see that prop 1 in is at the center. Can you see? It's at the center. It can be used to form other organic compounds. We are at 6.1.1. Right, write down the type of reaction represented by A. What is the reaction that is represented by A? Okay, that's what we want. Guys. The type of reaction that is represented by A. You can see that the arrow is moving from an alkene going to an alkane. Can you see that, guys? From an alkene going to an alkane. And now, according to our summary here, when we move from an alkene to an alkane, it has to be addition reaction. So it's addition reaction. That's the reaction there. So the reaction is addition there, because we will be adding two hydrogen atoms. Two hydrogen atoms were added, so hence it's going to be hydrogenation. And but the type of reaction that we have there, it is what? Addition reaction. Okay, that's what we have. So you'll get yourself 1 mark there. So let's go to question 6.1.2. They want the type of reaction that is represented by D. So we're actually focusing on D now. D, it is this arrow here, or you can actually look at this black arrow. Can you see this black arrow? That is going to the alkene. This black arrow is actually going to an alkene. So we're actually moving from compound X, which is a major product. It's a major product from compound X to an alkene. Guys, on this question here, okay, so it is what type of reaction that is happening here? It's elimination. So it's elimination reaction, and they will get 1 mark. Okay, let's go to 6.1.3 now. This is 6.1.3. We are now focusing on F. Okay, on F. So we already know that from an alkene going to product X, look at the arrow that is going to product X. We know that's gonna be a haloalkane. Okay, that's very important. Okay, now let's go to reaction F. Reaction F, we are from an alcohol going to a haloalkane. Can you see that writing this was very necessary? So it means you have moving from an alcohol going to a haloalkane. I know that's going to be hydrolysis. Can you see that? An alcohol going to a haloalkane. So it's hydrolysis reaction, or you can say substitution reaction. So we are adding the HBr, the hydrogen and the bromine. The hydrogen and the bromine will be added to produce a haloalkane. Can you see that, guys? So that's what is happening there at F. But what type of reaction is that? We know it's going to be substitution, and you will get your mark there. Now let's go to 6.2.1. The name or the formula of the catalyst for reaction A. Now they want the name or the formula of the catalyst for reaction A. Let's look at reaction A. We are moving from an alkene to an alkane, and we know that this is hydrogenation, and we know the catalyst there, it is platinum. Okay, it is platinum or palladium or nickel. That is the catalyst that is needed there. Okay, you take a look at your summary. From alkene to an alkane, what do we need? Platinum, palladium or nickel. You only use one. Okay, so we have got our mark there. Let's go to 6.2.2. Name or the formula of inorganic reagent needed for reaction B. Guys, if they say inorganic reagent, so it means they mean for a compound to be organic, it must have both the carbon atom and the hydrogen atom. That's what we mean. All right, so now let's look at this. The inorganic reagent needed for the reaction B. This reaction B, can you see we're moving from an alcohol to propene? Alcohol to propene. So it's alcohol to an alkene. Look at this. Alcohol to an alkene. What is that, guys? What is the reagent that is needed here? The inorganic reagent. So we know that's going to be the concentrated sulfuric acid. So this is concentrated here. Concentrated sulfuric acid. Concentrated sulfuric acid. That's the inorganic, because we are going backwards. We are moving from an alcohol going to the alkene. So it has to be the elimination reaction, and it's going to be dehydration. And for us to perform dehydration, we need the concentrated sulfuric acid. Very important, guys. All right, so let's write that. So the inorganic reagent here is the concentrated sulfuric acid. That's a 1 mark. 6.2.3, guys. The type of addition reaction. The type of addition reaction represented by C. Now we are looking at C now. C is from an alkene to an alcohol. Can you see? All right, we are going forward. This is forward, guys. This will be forward. This will be forward. But the reverse was the one where we added the sulfuric acid, right? Which is that there, which is the dehydration. So B is dehydration, but C is what? Hydration. This is what is happening here. From alkene to an alcohol, it's going to be hydration, but when I go backwards, it's going to be dehydration. So forward is hydration. So here what is happening here at C is hydration. That's what is happening there, guys. Okay, hydration. So the type of addition reaction, now they want you to be specific. Be specific. That's why they're saying type of addition reaction. They want you to be specific. Right, so now the type of addition reaction, we know it's addition, but what type of addition is that? Look at this, it's addition. The type of addition is what? Hydration. Okay, so it's hydration. You write there hydration. That's your mark. All right, now they want the IUPAC name for compound X. That is question 6.2.4. the IUPAC name for compound X. Now let's go to compound X. This is my compound X. It's a haloalkane. But how did we form that haloalkane? We have added the hydrogen bromide. We're moving from an alkene, we added the hydrogen bromide to form that haloalkane. So to get that IUPAC name, let's write the reaction itself. What is happening? All right, 6.2.4. 6.2.4 here, and then it's going to be prop 1 in. I know that is 3 carbons, 1 2 3, and the double bond is there. Okay, we add the hydrogen here. This is my propene, that is propene. But what did we add? We added the hydrogen bromide, so it's plus H Br. Okay, and then what are we going to form? We are going to form a haloalkane. Okay, but it's under what reaction conditions, guys? If we add a hydrogen and a bromide, look at this. We're adding a hydrogen bromide. I am crossing from an alkene to a haloalkane, so it means I'm going to need no water. Okay, so it's no water. That's the reaction condition. All right, and I showed you last time that the only way to memorize this reaction condition is to say, oh, I am moving from the alkene, from the point alkene going to the point haloalkane. So I'm crossing, this is like a bridge. For me to move from one point to the other using the bridge, I do not need the water, because if there's water, I'm gonna drown. That's how you're going to remember these reaction conditions. Are we together, guys? Very important. Alright, let's move on. So the reaction condition is no water, so it's no water there. And why do we need no water, guys? It's for us not to form an alcohol. We don't want to form an alcohol. That's why we don't need no water. Okay, so we're going to form a haloalkane there. It's still 3 carbons. 1, 2. This is going to follow the Markovnikov rule. So we're going to follow the Markovnikov rule. And what does it state? You just look at the carbons that have got a double bond in between them. Okay, which carbons are those ones? So it's carbon number 1 and 2. They have got a double bond in between them, which means they are going to be affected by the Markovnikov rule. But what does the Markovnikov rule state? It states that between carbon number 1 and 2, because they are so special, they've got a double bond in between them, they are going to say, oh, the carbon that has more number of hydrogen is going to receive another hydrogen. So between carbon number 1 and 2, which one has more number of hydrogens? So we can see that that's carbon number 1. So carbon number 1 is going to receive the hydrogen. It's going to receive it. Okay, this hydrogen here is going to go and bond here, because carbon number 1 has more hydrogens, so it's going to get more richer. It's going to be more rich, okay, in hydrogens. And then what about this Br, this bromine? This bromine, it will have no choice but to come and bond there. So it has no choice, right? It will just bond in carbon number 2. We're together, guys, right? Okay, so what we're going to form here, in carbon number 1, there's going to be a hydrogen. Okay, and then in carbon number 2, we know that there's going to be a bromine. That bromine there, this is my Br. Okay, and then this is going to be my hydrogen. Can you see that we have broken the double bond? So this is addition reaction. Addition reaction, from an alkene to a haloalkane, we are always going to break the double bond of an alkene. So the double bond is broken. Now we have single bonds in between the carbons. Are we together, guys? Very important. Okay, single bonds. That's what we're having there. They want the IUPAC name, so we're looking for the IUPAC name of this guy here. Can you see this guy? We want the IUPAC name. So therefore, the IUPAC name that we have there is going to be, because the bromine is in carbon number 2. This is carbon number 1, carbon number 2, carbon number 3. The bromine is in carbon number 2, right? It's in carbon number 2. And then there are 3 carbons. So the IUPAC name is going to be 2-bromo. Okay, 2-bromo propane, because it's a haloalkane, right? 2-bromo propane. Alright, so that's the IUPAC name, guys. I hope you understood this. I hope you got this. Alright, so now we are done with that. Done. Let's go to 6.3 now. 6.3 says, write down the structural formulae using a balanced equation for reaction B. Now we are looking at reaction B, guys. Where is reaction B? Reaction B is from a major alcohol to propene. A major alcohol to propene. Alright? We want a balanced structural formulae. Guys, we don't know anything about this alcohol, but look at the arrow. Look at the arrow going from a haloalkane, and we know our haloalkane, right? It is 2-bromopropane, this haloalkane here. Look at the arrow E. Look at the reaction E. Alright, look at this. Let me even indicate there. This is E. This is E, guys. This is arrow E. Can you see that? That arrow. Look at that arrow. we are moving from that haloalkane, and our haloalkane is 2-bromopropane. We are going to an alcohol. Do we know that alcohol? Yes, automatically we know that alcohol. We know it. That alcohol is going to be in carbon number 2, because this haloalkane, which is 2-bromopropane, the bromine was in carbon number 2. So also the OH is going to be in carbon number 2. So it's going to be something like this: 1, 2, 3. Alright, so the OH is in carbon number 2. So here there's an alcohol. This is the alcohol. This is my alcohol. It's a secondary alcohol. It's in carbon number 2. This is carbon number 1, carbon number 2, carbon number 3. Can you see that? So why are we saying this OH is in carbon number 2? It's in carbon number 2 because this haloalkane here, which is 2-bromopropane, the bromine is in carbon number 2, and also the OH is going to be in carbon number 2. Very important. So now let's write the structural formula of reaction B from this alcohol going to propene. Let's look at it. So I'm going to write it down here, write it down there. So we're moving from our alcohol. We know our alcohol now. Our alcohol going to 6.3 now, 6.3. But what is happening here, guys? Look at what is happening. From an alcohol to propene, look at your summary. What do we need there? What do we need for this reaction to happen? From alcohol to an alkene. From an alcohol to an alkene, we only need the concentrated sulfuric acid. Only the concentrated sulfuric acid, guys. Alright, that's what is going to be needed. So because the reaction is going to be dehydration, which is elimination. Alright, so we only need the concentrated sulfuric acid. That's what we need there. And then still we're going to form 3 carbons. 1, 2, 3. We're going to remove the OH. We're going to remove water, because the sulfuric acid acts as a catalyst and a dehydrating agent. Dehydrating agent meaning that it's going to remove water. So we're going to remove water here. We're going to remove the OH and the hydrogen in carbon number 1. Okay, so we're going to remove this guy here, must be removed. Okay, together with this guy, they are going to form the water molecule. Okay, so we're going to have a double bond after removing the OH and the hydrogen, because the carbons are going to be unstable there. The carbons will need 4 bonds around them, so we'll need a double bond because we have removed the OH and the hydrogen. So carbon number 1 and carbon number 2 are going to be affected, while carbon number 3 remains the same, it's not affected. Can you see that, guys? Very important. So now let me put my hydrogens. This is my hydrogen here, and then we're going to form water. Let's form that water molecule plus, because they wanted the structural formula, I cannot write H2O. No, you're not allowed to write that. This is molecular formula. It's molecular formula because it's showing the number of hydrogens and the number of oxygens, which is 1. Can you see that? So this is molecular, it's not structural. So this is wrong. You have to write the structural formula. So the structural formula is like this. This is the structural formula. Put the hydrogens here, and then my hydrogen here. Can you see that, guys? So that is the structural formula that you were required to write. Can you see? And they said it must be balanced. Balanced meaning that the number of carbons on the left must be equal to the number of carbons on the right. Can you see? It's 3 carbons on the left and then 3 carbons on the right. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens on the right. Let's see on the left hand side. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 hydrogens on the left. So it's balanced. So that is your 5 marks, guys. This is your 5 marks. you have your 5 marks right there. Alright, let's go to question 6.4. Question 6.4 now. 6.4. Both reactions D and E take place in the presence of a strong base. Okay, state two conditions that will favor reaction D over reaction E. So we're only focusing on reaction D. We want the reaction condition or reaction D. Reaction D, we said we're moving from a haloalkane to an alkene. Look at that. A haloalkane to an alkene. We will need what? Heat. High temperature. So it's high temperature or heat. That's what we'll need there. That is my high temperature. You'll get 1 mark. And then concentrated strong base in ethanol. That's what I'm going to need. Concentrated strong base or concentrated sodium hydroxide in ethanol. That's the second mark. Guys, you've got 15 marks here. We've answered every question. And that's it from me, guys. Please subscribe, hit that like button so that when I post videos you will be notified. Okay guys, so thank you very much for watching. God bless.